Yeah. Maybe that's why it had wrong time. I'll tell them to get a new clock or fix that one of the two. Okay, what I want to do is continue from yesterday regarding, yeah. Okay. No, depending on where it is in the fraction. Okay, so let's look at this here. Okay, these are all fractions, right? Okay, so here we would multiply everything on the top and then divide by everything on the bottom. So we would go 34.4 times 1.609 times 1, and 1 doesn't, and then hit and then go divide by 60, divide by 60. So each time you have a number on the bottom in the denominator, you're hitting the divide key. On the numbers on the top, it's multiply. And if you do it this way, the way I outlined it down here, you don't have to have intermediate steps. And your calculator keep it all internally. So you don't run the risk of writing down the wrong number or something like that. That makes sense? Okay, so regarding lengths, we have only talked about one-dimensional lengths. Okay, how long is this ruler? Not what's the area of the ruler or what's the volume of the ruler. We've not talked about that at all. So if we look at, for example, feet and inches, okay? You all know there are 12 inches to 1 foot, right? But how many inches, square inches, are in a square foot? That's right. Okay, to find that out, he already knows what it is. To find that out, if you didn't know that, what you do is, now area is called square, okay? And the reason why it's called square inches is because the units and numbers are all squared. So if we square this whole thing, from algebra, we're going to look at the exponential rules for this. So this square applies to that, 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 and to that. So what we end up with is 1 squared, the unit ft squared, 12 squared, and inch squared. So if we simplify this, we're going to have 1 square foot equals 12 squared, which is 144 inches squared. So that's how they came up with the 144. Now, if we go 3 dimensions, volume-wise, do the same thing. So all we did is volume is cubic now. So that's the exponent's 3. So we're going to apply that 3 to all of them, just like we did up here, only it's going to be 3 now. So this same process we're going to do here. That's how we got that. And then 12 cubed is, I don't know what 12 cubed is. So the numbers go up dramatically. Yeah. Oh, it is. Yeah. See, I misread my own calculator. Okay, so does that make sense? Now this applies to any length. I'm talking about inches, feet, yards, miles, centimeters, decimeters, meters, kilometers, whatever. Okay, anything lengthwise. We also have area versions of it and volume versions of it. Okay, so what would a problem look like? Is everyone okay on how I derive those? That makes sense? Now, you don't need to worry about the derivation of it. You just need to know that if we're talking about volume, you need to cube it. Talking about area, you need to square it. If you're thinking about just plain old length, you don't have to do anything. Because they're not going to give you the square versions of everything or the cubic versions of everything. They'll give you the one-dimensional length versions, and you've got to figure out what the others are. Okay, so something like so how many square inches are in 49.3 square meters? Okay, so what's given? All right, so we're going to calculate square inches. Okay, so given, calculated. Okay, so now we need some conversion factors to go from meters to inches. There's no direct one. So if we look at here, and we've got inches and centimeters. Okay, and we can go from centimeters to meters. So inches. So what do you want to do first? Okay, so let's go to so how many centimeters are in a meter? How many cents are in a dollar? How many centimeters are in a meter? 100. And because it's squared, we have to square that. So that's now our conversion factor. So this is going to be 100 squared here. Okay, so now we have square centimeters. And if you look over here, we have centimeters and inches up at the top left, 2.54. And notice it's bold-faced, so that means it's infinite precision. Okay. So we have it's just a matter of cranking this baby out. Does everyone see where I got the conversion factors? Yeah, because we're working in square area, we have to square everything. Now, a lot of questions come up. Why didn't I square the 49.3? A lot of people ask that. It's already squared. So if you square it again, you'll mess everything up. So it's because it's already squared. We're not going to square it again. These others were not squared. That's why we had to square them. Okay, so we're looking at now the way you do this in your calculator is you're going to go 49.3 times 100 caret 2 divided by 2.54 caret 2 enter. Now that's probably one of the more trickier problems. On your dry lab number 2, the last 2 problems, or the last problem is a volume or area problem. I forget which one. So today's lab we're going to be doing 2 things. The dry lab is pretty long. It's pretty long. So regarding dry labs, some of you do these more quickly than others, which is fine. And when you're done with a lab, you may go home. However, if you would like to do, because a couple of days ago, some people were having some blood sugar problems, and I just told them just finish this lab up at home. So if you want to finish the dry lab up at home, that's okay. If you'd like to leave earlier for whatever reason, or you can stay the whole time. Okay, I'm very flexible that way. Yeah. I'm sorry? The power of 3?
Yeah.
Still not following you.
Be under the value of 1 for it to be a positive power.
Well, a meter's this big, right? Inches like this. So there's gonna be a whole bunch of inches in that big meter. So the number is gonna be big, not less than 1.
Oh,
If it was flipped, if I said how many square meters are in 49 square inches, then the number would be really small.
well, scientific notation. That has nothing to do with it.
Right. So what's wrong with the scientific notation?
I thought that's what he was talking about. But he was saying it's kind of the third. Content of the fourth. Okay, well, he would say you do it.
All right. I like people to check my work though, because
Yeah.
I'm old and make mistakes. More than you want to know. All right. So what we're going to do is I'm going to do one more problem, this time with volume. And then I'm going to wrap it up for today. Now, you're going to have a test coming up next week. So I'm going to be reviewing a lot, and I'm going to show you an example of test 1 from last semester or semester before or whatever, just to get an idea of how long the test is and the format of the test, that kind of stuff. Let's see, we'll do the test tomorrow, the review test tomorrow, review on probably Tuesday. Okay, so you test me on Tuesday. Yeah.
Hold on, 5 minutes. So you know what those, what those days are?
No, because I'm not used to teaching in an 8-week. I'm usually teaching 16 weeks. So I need to redo the that. Basically, there'd be a test about every week and a half. 5 tests into 8. So but figure every week and a half you'll have a test. What days I need to figure that out more precisely.
So on the days of the test, do we have lectures?
No. Okay. This question was the day of the test is the day of the test. That's all you were doing that day.
Lab.
We're having a lab that day. So
So after the test, go to lab.
yeah, but not, everyone's not going to finish at the same time though. I'm going to give you an hour and 15 minutes to do the test. It's a 45-minute test, so you should have ample time. So, and okay, any questions about this calculation? Okay, so let's do one similar to this, only okay. How many cubic meters are in 49 cubic inches? So this is going to be kind of a 1 volume and 2 kind of the reverse. So we now remember cubic meters, that's a meter by meter by meter. A cubic inch is an inch by an inch by an inch. So there's going to be not very many meters in that cubic inch. In other words, we're going to take there used to be a meter stick in here, I guess. Oh. Okay, so we're starting with 49.3 cubic inches. We want to end with cubic meters. So remember again, we have 2.54 centimeters per inch. And then we have 100 centimeters per meter. Okay, so first thing we need to do is I'm going to convert the inches to centimeters. So that's 2.54 cubed. Now we have cubic centimeters. Now we need to go to cubic meters. All right, so so is the number going to be small or big? Going to be really, really small. It's going to be 1 cubed is 1. So
Correct.
yeah. Yeah, for completeness, you can put it there, but calculation wise, you're right. Okay, it's going to be very, very small because how many of these square meters are going to stuff into the little bitty cubic inch? So if your answer is not very tiny, your setup is wrong or you calculated wrong. So just think about your answer. Is it reasonable? Is it reasonable? So to do this, we're going to go 49. And again, I'm not going to cube the 49 because it's already cubed. So the given, when you're doing area and volume, the givens are already in that square or cube configuration. Do I always what? Yeah, between my ears and that ventilation system, it's hard to understand you. Oh, yeah. Yeah, always squared or cubed. It's never fourth or fifth or anything like that. No, it'll always be given. I'll just say, convert this to that basically. So you actually are able to hear him, eh? Young ears. Okay, so I got a really small number, which we should have a small number. Now, there's two kinds of hard problems in Unit 1. One is area volume, which we just did. The other one are long conversions. We have multiple steps. Now, when you're doing your dry lab, the fourth and fifth problem, put it the further down because you're going to have 2 easy problems or 3 easy problems. They're going to have 2 hard ones. And in my opinion, those should be further down. So skip those and come back to them. Problems, I think it's 4 and 5. They're kind of related. They're very similar. It has to do with tablets in a gram and a dram and bottle and cost. Unless you're comfortable doing them, that's fine. But if you find them kind of tricky, just move on. Now that goes for all problems on a test or on a worksheet. Skip the problem and come back to it if you find it difficult, or just try a setup and come back and keep plugging away at it. Make sure you have a big eraser. Be your best friend in this class. Is an eraser. Indelible ink is not your friend when you're doing worksheets. Okay, so that's what I wanted to cover today. And I want to end a little short today because our lab is going to be long today. Because we got to check in, get an inventory in the drawer, and then we have to do the dry lab. So there's a lot to do in the dry lab today. Now, if you don't finish the dry lab, for example, say you just petered out halfway through, it's not due for a week. So if you want to finish it at home or come in the next day, say you're doing a Monday lab or Wednesday lab, and you want to come in onto the Thursday lab just for asking me questions, that's fine too, because we have room. As we go into the semester, there's going to be more and more room. So coming in on off days is fine with me. And you don't have to check with me first, just do it, okay? All right, any questions about this volume problem? Okay. Oh. Well, the conversion factor would be how many nanometers are in a meter. So yeah, it goes 1,000, million, billion. And that would get you to meters. Well, it depends on how you're converting, but and there's two ways to do that. It's 1 nanometer is 10 to the minus 9th meter, or 10 to the 9th nanometers equals 1 meter. And they're both the same thing, and either one will work. Okay. Well, there's a base unit. I gave the example of using grams, but it could be meters. You know,
I think I got it. Yeah, I get it. Okay.
see, there's two of them.
Where's
See,
nanogram?
is equal 10 to the minus 9th gram, or 10 to the 9th nanograms. That should be it. And yeah.
Okay, yeah.
Nanograms in a gram.
Gotcha.
And they're both conversion factors, and they're the same thing. They just look different, but they're the same conversion.
+9 and -9 are the same aspect of it.
Yeah, because
Okay.
let me pause this record here. Okay, everyone, I'll see you in lab.